Okay, today's video is going to be about integrating your project with DynamoDB. So first we're going to take a look at one way to design a DynamoDB table. And a easy way to do that is with a spreadsheet. So as you can see here, we had a primary key and all the attributes in the table. So the primary key is going to be made of a partition and a sort key for your project. So this spreadsheet is based off of example database for the COVID simulation project, and that's what I'll be showing you in a minute. So it's going to have the simulation number is going to be the primary key, so whatever simulation you're running, and the sort key is going to be all sorts of things like stats, and we're just going to be showing stats in our example today just to keep it simple, but you can add the defaults, the time it started, time it ended, performance indicators, all sorts of things to your database. This is just what an example database would look like, just with different kinds of sort keys with different kinds of attributes. So that's one way to design your database. Really simple, really easy. So if we go to our COVID simulation data, what we're going to do is we're going to run it. And, oh, whoops, I ran the delete method, which we'll go over in a minute. So let me delete all these items real quick. You can skip this part of the video if you don't want to watch me delete items. So this is just some example items we already have pushed in, but we're going to push in a bunch of more items with a sim ID of 2 so they don't overlap in main. So if we run main, we're gonna run the simulation, and I added in a method in control where it counts the number of people infected every frame, and if that number of people is 0, it means it's over, and it's going to stop the timer, and we're going to push the data to the cloud. So the data we're going to push is walls and persons, and so I just added some tracker variables, and so did Andre, to the wall and people class, and in the wall class they actually aren't being updated. Oh, you can see it's done. Pushed all those people up. Each one of these numbers is one push and pushed up, or one thing pushed up. Sorry, I can't talk. So as I was saying, these variables are just example variables. These aren't actually being kept track of in this program, but it's just an example of what you might keep track of in your project, just for what you want to push up. And in person, these variables are being kept track of, maybe not accurately, but it's just to show an example of pushing data for each person, unique data for each person to the cloud, and data for the walls to the cloud. So in your project, I don't know what your project is about, but hopefully you'll have some understanding of what you might push up instead of a person or a wall, and what data you want to keep track of for those things. So in main, we're going to call push data, where we push up every wall and then every person. And we're going to use threads to push up, because normally when you push up, you need to wait for AWS to tell you the previous item was pushed up to push up the next item, which is really time consuming. So if we put them into threads down here, where we have the class that extends thread, all of its local variables that get updated with its 2 different kinds of constructors, depending on if it were pushing a building or a person, and run. And all we have to do is say the class that extends thread, we say start, and that'll do the run method. So by using threads, we can push all of them up simultaneously, which is much, much faster. And maybe we'll show that in a minute. So then we go through all the buildings, push those up, and model is the people. So then we go through all of the people and push each person up. And I made the walls and people static so we can access them from main, just for simplicity. And this is just some code for what kind of data I want to push up. So I pass it these different variables essentially to the cloud pushing class that extends thread, and they have local copies And then depending on if we're pushing a building or a person, we're going to call the add data method add builder add person. And in here, this is going to be MVC, so this is model. And this would be a combination of view and control, which in your project you'd hopefully have separated, where frame would be view and control is control and main is control. And then this would all be model. So in add data, we have add build, and we actually don't need these local variables here, but the idea is we take all these parameters and we push them into a new item in the cloud with the simulation ID, the stats, which is the sort key, and so on. As you can see, it's pretty simple. And we already talked about how do you load a new item. So yeah, same thing with the person. Based off of the parameters, make a new item. So if we go in here, we can see we pushed up a ton of new items, each with pretty unique things for the people because those variables are being kept track of, and the buildings are just not being kept track of, but that's the idea. So that's why they're all the same variables. But this is a really good example of why DynamoDB is so useful, is because it's not really structured. It doesn't have a schema per se. So you can have these building items that don't have anything to do with the attributes associated with a person, but just have the building attributes. Same thing with person, make a new person, which have totally different attributes than a building. And you can just say that by creating an item with new attributes, and you don't have to restructure the table at all. It just does it for you. So that's why it's really useful. So DynamoDB is really useful for large amounts of data because it's really easy to scale and it's not super structured, so you can add new items. So now we can, if we want to, I'll show you an example of what it's like to push up the data without threads. So let me just delete all this so there's no overlap when we re-push up data. So if we tried to push up all the data without using threads, and we just called it straight from here. So this is the same method that is called down here, add_boy.add_person or add building. So instead of calling it a thread, we're going to call it in here, so it doesn't happen simultaneously. And we'll be able to see just how slow it is. So before, these numbers in the console appeared almost instantly when the simulation was done. But now, if we run the simulation, we just gotta wait a minute to finish so you can skip this part of the video to where this simulation is done. But for now, we'll just wait. Fun, fun, fun. Oh, looks like it's almost done. There we go, and we're done. So now you can see it is pushing up each item at this pace. So it pushed up the 7 buildings, now it's pushing up the 99 people. So as you can see, it's going pretty slow for if you want to push up a ton of data, that's very, very slow. So we're just going to terminate that. And it did push up the data, some data that was being shown, but we're just going to delete that because we don't need it. And so that is the advantage of using threads when pushing up large amounts of data to the cloud. So Andre's videos already went over. Or I'll go over the adding items, which we basically already went over, but this is just a class that Andre created where you just pass it a bunch of parameters and it makes the items based off the parameters, which we already know how to do. So if we want to query, Andre coded this as well, and he already went over had a more in depth how querying works in his other videos, so you can watch those. But we're just going to show a quick example. So one is going to get person 64, one is going to get person 27, and this one's going to get a specific attribute. This one's going to get the whole item. Oh, right, we need to rerun the program to get the data back in the cloud. Once again, skip this part of the video if you don't want to watch the whole simulation, because we just got to get new data into the cloud. Sorry if this video is kind of long. Just want to make sure you guys have a clear example on what your project could look like integrated with DynamoDB. So there we go, it's done. As you can see, the numbers appeared really, really fast because of threads. Great example. So now if we want to query, we can see that the data has now been pushed up. So we're going to query for person 27 and his collisions, and person 64 and his number of collisions. Whoops. This thing is really annoying. I keep clicking on it. I should move it. Okay. So if we run it, we'll get the number of collisions for those two different items because we queried for them. The first one returned an item, so we just got the specific attribute of that item, and the second one returned the actual attribute, so we can just print that out right away. So that's querying. So that's something you could do in your project. Well, something you'll have to do is query your database, which could be really big or really small, who knows, depending on your project. But this is how you'd query. And next we can see how we would delete a specific item. And it's very similar to querying, except with a delete item spec. And there's a million different ways to define a delete item spec, but we're just going to do it with primary key. And so we're just going to delete item spec with primary key and pass it the primary key, which is made of the partition and the sort key that we pass it, in this case, to person 64. So if we run delete, we'll see that person 64 is no longer there. There, 63, 65, he's gone. So that's basically how we integrated DynamoDB and AWS with the COVID simulation project. So your project probably won't be entirely like this, hopefully, but that's just the idea, to integrate DynamoDB with your project and create a spreadsheet-like example table so you can know what you're working with, and then start creating that table in AWS. And yeah, so that's what the project's going to be, integrating DynamoDB with your project. And this was an example of how to do that.